All right, so we're going to look at the second half of law of sines. So it's still section 8.1. We're going to look at the cases where there's no solution and two solutions. All right, so we'll just start off with an example. Okay, just as a reminder, in case you don't remember the law of sines, okay, it's sine of alpha over A equals sine beta over B, and then equals sine gamma over C. Right. Does anybody remember how you can look at the table and tell that this is a law of sines problem without making a sketch and figuring out if it's one of the three types? Yep.
Two sides of an angle?
Not always, because we're going to have a case tomorrow where we have two sides and an angle, but it won't be law of sines. But it's something about how the sides and the angles are laid out in the table. Brian?
You have at least one area where you have both the side and the angle are found that are opposite each other.
Yeah, we have one row that's complete. And if you drew the picture, this side A and this angle alpha are opposite each other. Yep. So having a row that's complete tells you it's law of sines. And how can we tell that this is the case that we have to be careful with? Something else about the table. Mm-hmm.
We only have one angle.
Okay, we only have one angle. We also have a row that's empty. Okay, anytime you have a row that's completely empty and you have no way of finding anything in this row right away, it tells you it's the case where you have to be careful. All right. If you weren't sure by looking at the table, you could always make a sketch. That's A, alpha. You could put B, beta, C, gamma. Right, so this is side, angle. Okay, so any questions why this is going to be law of sines or why it's side, angle? All right. Whenever you're doing side, angle, you have to find things in a certain order. So what out of C, gamma, and beta, what's the first thing I have to find here?
Beta.
I have to find beta. Okay, I can't do anything in this last row. Okay, not till we find beta. All right, so we're going to set up. Does anybody remember what this is called? The two fractions equal to each other? Yep, so we set up a proportion. And then we cross multiply to solve it. Derek, what could I put on the left side of my proportion?
You would put sine of 35 degrees over 6.
Yep. So we're going to use that top row here to do a lot. Okay, sine 35 over 6 equals, now we're going to put sine of beta over 8. All right, so you can cross multiply, or in this case, just multiply each side by 8. 8 sine 35 over 6 equals sine beta. Okay, Dominic, what would I do from here to get beta by itself?
Inverse sine.
Yep, I'm going to take the inverse sine of what's on the right and what's on the left. And when we type this in, if we get no solution, okay, then we're done right away. If we get an answer for this, then it's not no solution, and then we have to check for the second solution. All right, so we'll type in second inverse sine. Now, 8 sine 35 over 6, but we're going to have to be careful with our parentheses. All right, so we got 8 sine 35, and I need to close my parenthesis right there, over 6. Close it again for inverse sine. One more thing I want to check before I hit enter. Yeah, my problem is in degrees, and I am in radians. Okay, so I want to change to degrees. Enter. All right, so this is not no solution. This is one solution right there. 49.886. Okay, now I'm going to write that answer up higher in the box just in case there's a second solution. And if there is, I'll put it below it. Okay, now we're looking for where sine equals a positive number. What two quadrants is sine positive? 1, and we just got that answer. And then quadrant 2. How do we get the quadrant 2 answer using that? Yep, 180 minus 49.886. Okay, so I'm just going to write that off to the side, and then we'll check and see if it works. 130.114. So if there's a second answer, this is what it is. How do I check and see if this answer works, or a hint might be, does it fit? Yep.
For example, if 130.114 plus 35 is less than 180, which it is, then it is a plausible answer.
Yeah, so what ends up happening here is you take the angle that was given, you look at what you think the second answer is, you have to make sure they don't add up to more than 180. Okay? This time they don't. They add up to 165.114. So beta has two answers. Okay, and if beta has two answers, what else do you think that means?
Gamma has two answers.
Yep, gamma has two answers. And C has two answers. Okay, so this problem isn't harder, it's just longer. We just have to do everything twice. Okay. So what I'll do is I'll put boxes around the things that are in the same triangle. Okay. We have alpha. Actually, a different color. Okay, that's in my first triangle. That's in my first triangle. And that's in my first triangle. Those three angles that I just put a box around, that's one problem we're going to solve. Okay? And this is also the side in the first triangle, and the first triangle. Okay, so everything in the red boxes, that's triangle 1. Okay, this is triangle 2. That angle, and that angle. So notice alpha is used twice. Alpha is in both. Okay. Beta 2 and gamma 2, just in the second triangle. Then we've got C2, B, which is in both, and A, which is in both. So there should be 6 green boxes up there, that's one problem, and 6 red boxes, that's a different problem. So how do you think we're going to find gamma 1? Those are the red boxes. What two angles are we going to use, and what do we do with them? Yep.
We take alpha and beta 1, add them up, and then subtract them from 180.
All right, so take alpha plus beta 1. So we're going to add those up, see what we get. And you said subtract that from
180.
180. So 180 minus 84.886. Okay, so we get 95.114. Okay, now at this point, we could go find C1, or we could just finish up gamma 2 and get all our angles. Let's finish gamma 2. Okay, what two angles are we going to add up to find gamma 2? 35 and the 130. Yep, beta 2. So that's going to add up to 165.114 and subtract that from 180. Okay, you get 14.886. Okay. Any question on that? And now we're going to find C1 and C2. What row do you think we're going to use to find both C1 and C2? Yeah, we're going to use this top row. That row is in both. Okay? We have other rows that are in both now, like 8 and 49.886. That's a row that's complete. And 8 and 130.114. Okay, we also could use that row for the second triangle. But it's better to go with the original row. Okay, so you're going to set it up just like we did when we solved for beta 1. At the time, we didn't know there were 2 betas, but now we do. Okay, and let's solve for, let's do C1. So we got sine 35 over 6. Okay, and what's going to go on the other side? Sine 0.114 over which one?
C1.
C1. All right, so okay, cross multiply, and then we'll have C1. Okay, so what is C1? Just tell me it's what times what divided by what. Yep.
It would be 6 sine of 95.114 divided by sine 35.
Yes. There's your answer for C1. Okay, any questions on how to type that in? Yeah, I guess we could type it in. So 6 sine 95.114. Okay, I'm just going to do that first. And then what was it? Divide by sine 35.
10.41.
Yep, 10, good, 10.419. Okay, and now we're going to do it one more time to find C2. Let's find C2.
Exactly the same as 95.114, 14.886.
Yeah, it's going to be the same thing. Just replace the 95.114 with 14.886. So if we see it's the same, why don't we just go right to the final answer? It's going to be 6 sine 14.886 divided by sine 35. All right, so we know 6 sine, well, actually I got to type it in again. 6 sine 14.886. Okay, divided by sine 35. Anybody else get 2.687? Okay. Right, now you can always check, make sure the biggest side is across from the biggest angle. So in the red triangle, the biggest side is gamma 1, and the biggest side of all the red boxes is C1. So that looks good. Smallest side is A, smallest angle is alpha. For the green triangle, smallest angle is gamma 2. So in the green sides, the smallest side should be C2. Yep. Okay, and of course, any 2 sides added together should be bigger than the third side. Right, so numerically, calculation-wise, this is how you can get 2 answers. Right, any questions on that? Right, the next thing I'm going to do is show you a sketch. Okay, I'm going to make a pretty accurate sketch of how you could draw 2 different triangles when you have side-side angle. All right, so I'm going to start with this triangle. All right, first thing I'm going to do is make a copy of that side. Okay. Does everybody agree that that side and that side are the same length? Okay. So I have a side. I'm going to take this side, I'm going to copy it, and I'm going to flip it. Okay, does reflecting or flipping it change the length? No. So this side is still congruent to that side. Okay. And the last thing I'm going to do is just put in my horizontal. Okay, I'm going to group all that together. And by keeping that line horizontal and the side with 1 tick mark at exactly the same angle, I just created a congruent angle in the lower left. Okay, everyone agree with that? Okay, so what I just constructed is 2 different triangles that have 2 sides and an angle in common. Okay, you can't do that with any other case. Side, 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 side angle, side, no. That's the only time you can do that. Okay, so any questions on visually how you can get two solutions? All right, so we looked at the two solution case. Before break, we looked at the one solution case. What's the other thing that can happen? No solution. All right, so let's go through the arithmetic first, and then I'll try to make a sketch of something that has no solution. All right, first thing, how do I know this is law of sines? Just looking at the table. Yep, complete row. And how do we know it's the case where we have to be careful? Yeah, we're missing an entire row, and we have no way of finding anything in that row until we find what first?
Alpha.
Alpha. Yeah, we've got A, so we got to find alpha. Okay, Jacob, can you tell me my proportion that I'm going to set up to find alpha?
Sine of 50 over 1, and then sine of alpha over 2.
Sine alpha over 2. All right, so really, since it's a 1 in the denominator on the left, we don't even really need it. Just double each side, and we get 2 sine 50 equals sine alpha. Okay, my next step is to take the inverse sine of each side. Okay, I'm going to do this one in 2 steps. I want you to see what 2 sine 50 is, okay, before I take the inverse sine of it. Okay, 2 sine 50. 1.53. And now I'm going to try to take the inverse sine of that number. So what's going to happen and why? It's not going to work. Why? It's greater than 1. Okay, you can't take the inverse sine of a number that's greater than 1. Okay, if we try, just take the inverse sine of the last answer. We get an error. It's not in the domain. Okay. This would be like graphing this function, which goes as high as 1 and as low as -1, and saying where does it hit 1.53. Okay, it doesn't. Okay, graph doesn't go that high. Right, so what that means is we get no solution for alpha. Okay, what does that mean about beta? Right, if you don't have alpha, you don't have anything to add to gamma and then subtract from 180. So we can't find beta. And if you can't find beta, you can't find B, because you have to know the angle across from the side you want to find. Right, so no solution is the fastest case because you're done pretty quick. 2 solution is kind of the opposite. Okay, you got to do everything twice. Okay, any questions why we got no solution? All right, now let me try to sketch this triangle. What do you think is going to happen when I try to draw it? I mean, it's not going to work, but what does that mean? It's not going to work. Any thoughts on how it'll look?
It will be open.
Open, like the sides won't connect,
Yeah.
kind of thing? All right, let's sketch it and see if that's what happens.
Yeah, it will be open.
All right, so I'm going to use this in a second to measure my angle out so it's exactly 50 degrees. Okay, but first thing I'm going to do is draw 2 sides. Okay, one of them has to be a length of 1, the other one has to be a length of 2. Doesn't really matter how you do that. Okay? If I just take that and clone it and put it next to it, then it's going to be twice as long. Okay, so that side is going to be my length 1. This is going to be my length of 2. Okay, any questions on that? And I'll just group those 2 together. Right, now the longer side is which one? A. Right, so I need A to be at a 50-degree angle. Right? So I've already measured out a 50-degree angle. Okay, and now I can't change that slant. Okay, I have to keep the slope just like that, so that way it stays at a 50-degree angle to the horizontal. Okay, so there's A. And now C, okay, that's going to be the side that side's going to come off over here. Now I can rotate this any way I want, but to rotate it, I don't know why, but I have to group it with something. And then I can erase that dot. Right? So now I can rotate that any way I want. And B can be any length I want. That wasn't specified, but I have to keep B horizontal. If I don't, I'm changing this 50-degree angle. Okay, so there's B. So is there any way that this third side is ever going to connect? No. Okay, it's too short. So to make this triangle work, you'd either have to do two things. What's one thing you could do? Eden?
You have to change the length of C to make it longer, or change the angle of the gamma to connect.
Yeah, make C longer so it can reach. And then if it could reach, it might be able to reach going off to the right or off to the left. You might be able to get two answers out of it. Or make the angle between alpha and beta, make gamma smaller. Okay, you could do either one of those things and it would work. Okay, a more advanced problem might be, let's say we leave C at exactly this length, and I told you this length. What is the maximum angle that gamma could be to make this problem work? Okay? And any bigger than that, and it wouldn't connect. Okay, that'd be a little harder problem to figure out. Okay, but it's still, it would still be doable. You'd have to think about the algebra a little bit. Okay, so any questions on this one? All right, so let's take a look at our two-word problems. Okay, I think these are both in your book, so if you want to reference that, you can, or you can just copy it as I'm writing it. All right, so this one's going to be about measuring the height of a mountain. All right, so it says a surveyor is going to measure the height of a mountain by taking two different sightings. And we don't know how far he is from the mountain. It doesn't matter. All we know is the distance between the two sightings is 900 meters. Okay, if you're looking in your book, let's see, this problem is I'll find it for you in a minute. All right, so we're going to do two sightings 900 meters apart. The first sighting results in an angle of elevation of 47 degrees. Angle of elevation is the angle that the surveyor has to look at to see the top of the mountain. So if we were to draw like a line right from his eye to the peak, it would be a 47-degree angle with the horizontal. That's angle of elevation. And to make this simple, we're going to assume that he's level with the ground. Otherwise, you'd have to take into account the surveyor's height up to his eye. Okay? So we'll just assume that he's level with the ground when he makes his sighting. Okay, now for the second observation, the surveyor is going to back up 900 meters. So what's that going to do to the angle if he backs up and still looks at the same spot? Yeah, it's going to make the angle lower. Okay? Just think if you were looking at like a screen in front of you and you're very close to it, you might be looking almost straight up, but the further back you go, the less steep the angle becomes. Okay, so the second observation results in a sighting of 35 degrees. Okay, we're going to, again, assume that the device he's using to measure is level with the ground. All right, so in this problem, there's a lot of information to kind of interpret. So what do you think a better way of interpreting all this information would be? Yeah.
Draw a picture.
Yeah, we should just make a picture and draw out all the angles we have. And then we're probably going to end up with a lot of triangles that we'll have to solve. Right, what's probably one of the most important things I need to have, well, two important things I need in the picture. Yeah, I need the mountain and I need the ground. Okay, so we'll assume that the ground is level. Okay, and we need our mountain. Here's our mountain. All right, and the surveyor is going to take two different sightings. Okay, let's just say one from here, one from here. We don't know how close those sightings are to the mountain, but we know how far apart they are from each other. And how far apart are they? 900 meters. Okay, and the surveyor is going to take two sightings to the peak. One, two. Okay, what's the angle of elevation from the sighting that's closer to the mountain? 47 degrees. That's the angle that, if he was level with the ground, he would have to look up at or use a transit or some instrument. He'd point that angle at a 47-degree angle. How about the angle for the second sighting? 35 degrees. And we're trying to find, we're measuring the height of a mountain. Okay, so that I should add that in. Find height of mountain. Right, so the height of the mountain, let's put that there. Okay, so ultimately that's what I want. That line in red, that's the height of the mountain. And remember, height is always measured perpendicular, straight down from the peak. All right, any thoughts what I can figure out first here?
Right at the point of the first point of observation, you can find out that angle that is behind him, which would be
Yep.
133 degrees because of supplementary number.
Yeah, we can find this angle inside this other triangle that has a base of 900 just by doing what Brian said. That's 133 degrees. Okay. All right. Now, you know what? Let me put the sightings in different colors so you can say either the blue line or the red line. So that'll be, actually, no, let's not use red. Let's use green. All right, what do I want to do now?
You can find the third angle and the triangle with the blue and the green.
Yep, I think we're going to need that third angle. How would you get that?
180 minus 133 minus 35.
Yep, 180 minus 133 minus 35. That gives me a 12-degree angle. Okay. So I think we found all the angles we really need to find for now. All right, so what would I do next? Right?
We can maybe set it up so the 12 would be alpha and the 900 would be A, and set it up so we can do log signs that way.
All right, so let's start out with that. So we got sine of 12 over 900. In this problem, I'm not going to label A, B, C, alpha, beta, gamma. Just make sure you always write sine of an angle, divide by what's across from it. Sine of an angle, divide by what's across from it. Okay, so now what side do we want to find? I think we want to find the green, right? We want to find the green side, okay? Because if we can find that,
35.
then we can find the red side, right? The green side is it's our hypotenuse in this other triangle with the height, okay? But we don't know any information about this right triangle other than the 47 and the 90. So we got to have a side.
Then we're going to use sine 35.
So what would that be? Sine what?
35.
Sure, sine 35. And we could call the green side
B.
B. Yep, we could call it B. So now we're going to find the length of the green side, which is B. All right, so what is B going to equal?
900 sine of 35 over sine of 12.
5 sine 12. Perfect. Okay, and because we actually want the height eventually as a decimal, why don't we find out what that is? So we've got 900 sine 35. Sine 35. And what was it divided by sine? 12. So 2,482.8. Yeah, we could say 0.88. Since we're measuring the height of the mountain, most heights are measured to the nearest foot. So if we go to 2 decimal places, that's probably more than we even need. So 2482.88 meters. All right, so let's write that in. I'm going to erase B and write that in. We'll just move B up above. So it's 2482.88. All right, now how could we find the height? Aiden?
Well, use sine n squared 1 over then always
Yeah, so you definitely could use law of sines here. Okay, the way Aiden just said, sine of 90 divided by 2482.88, and then sine of 47 over h. That would work fine. But is there an even simpler way? Trying to take advantage of this right angle? Yep.
Find the final angle between the green and red side at the top, because 90 degrees was 47 is 137, so 180 minus 137 would make that final angle up there.
Okay, if you wanted, you could find that angle, and you could use that angle. But you could also just use this 47. You actually don't need to find that third angle. But you could. It's just that. What trig function are you thinking, Brian?
Inverse sine.
Keep in mind, inverse is only used when you need to find an angle.
Oh, good.
We need to find a sine.
So we just use sine.
Sine of 47.
Is equal to 24, no, it's h over 482.
Yeah. Now you can go back to right triangle trig, and sine is opposite over hypotenuse. Right? Now you have a hypotenuse because you have a 90. So sine of 47 is opposite over hypotenuse. Okay, so the height is going to be sine of 47. And then what am I going to do with the 2482? Multiply. So times 2482.88. Okay, so the height is 1,815, we'll say 0.9 meters. 1,815. Bless you. All right, so I mean that's a reasonably tall mountain, but for the East Coast, but in terms of like huge mountains like Everest, you're probably looking at something that's up over 7,000 or 8,000 meters. So in terms of really, really big mountains, not that big. Mount Wachusett in comparison is probably, it's 2,000 feet. So divide that by 3 roughly, that's about high 600 meters. So it's like triple the height of Mount Wachusett, but not a huge mountain. Okay. Any questions on that? All right, so let's take a look at our last one. Yeah, it's a lot of description. This one, you know what, I think I got both of these from a different book. That's why they're not in your book. All right, so for this one we have 2 Coast Guard stations. These are almost like our sightings, okay, in the last problem. And we know the distance between them. Okay, it's 120 miles between the 2 Coast Guard stations. Okay, and they've named the 2 stations Zulu and X-ray. So when we draw it, we want to make sure that we put Zulu to the west of X-ray. Okay, we don't want to flip that. Okay, and we're going to have a ship out in the ocean, and let's assume that the ship is sending an SOS because maybe their GPS doesn't work. Okay, so they don't know exactly where they are. It's cloudy, so they can't see anything, in the sky. It's nighttime, so they can't see any land. So they don't know where they are. They have no reference point. And the person who was supposed to keep track of their position the last time they knew their position forgot to do that. So now they have absolutely no way of knowing where they are.
That's just horrible.
Yeah. All right, so the ship sends out an SOS, and each station can hear the signal. Okay, the first station hears the signal, and they're able to indicate that the signal is coming into their station at a 40-degree angle. Okay, and it's coming in at a 40-degree angle east of north. Okay, from the perspective of their station. So we'll sketch that in a minute. Okay, so the first station says we're receiving the signal at an angle of 40 degrees east of north from our perspective. Okay, and the second station says, well, we're receiving the same signal, and it's coming in at an angle of 30 degrees west of north from our perspective. All right, so now we have 2 stations that are receiving the same signal from the same source. Okay, so they should be able to pinpoint where that source is coming from. If we had a third station, we could even, this is called triangulating opposition, we could triangulate it even more accurately. Okay, but for this kind of problem, you need a minimum of 2 stations. If only one station could hear the signal, all they could do is tell you it's coming from that way. They could just point in a direction. They wouldn't know if it's a mile away, 50 miles away, or 100 miles away. They could tell you a line that the boat could be on. So since each station can tell you a line that it can be on, we'll figure out where they cross. And that's where the boat is. Okay, so we're going to figure out how far each station is from the ship. A couple things we're doing to simplify it is we're assuming the ship is staying still. Okay, which most likely in real life wouldn't be the case. Okay, if you had a current, drifting, causing the boat to drift, if it had no power, you'd have to take into account not only where the boat is now, but where the boat will be. So let's say once we figure out these distances, let's say, they're 300 miles away. And the Coast Guard station says, well, it'll take us maybe 3 hours. We have a helicopter that flies at 100 miles an hour. It's going to take us 3 hours to get there. They can't fly to where the boat is now. They'd have to fly to where the boat will be in 3 hours after it drifts in the ocean. So there are things that would make this a little more complicated. Okay, but we're going to assume the boat stays still. All right, so first thing I think we should do is just try to make a sketch of all this information. Okay, a lot of information. Okay, this time, what we really need is the shoreline that gives us where the boat could be in the water, and then the Coast Guard stations will be on land. All right. So we'll do this. This area is going to be my water, and this area will make land. All right. So we've got 2 Coast Guard stations, okay, and we're going to assume they're just positioned right on the border between the land and the water. One here, one here. Okay, how far apart are the stations? Yep, 120 miles apart. Okay, and we have a boat. Is our boat? We don't know that the boat is centered between the 2 stations, okay, and this might not be to scale. It could be closer to one than the other. Okay, so just, that's how I drew it. Okay, what's the station that's to the west? Yeah, it says Zulu is west of X-ray. So let's call this, you know what, I'm going to make these, I'm going to make these dots so it doesn't look as confusing. Okay, we'll make this one Z and X. All right, and each station is receiving a signal from the boat. Okay, so I'm going to draw in the signal they're receiving, just like that. And now the angles are referenced from north. So what I need to do at each station is just draw a vertical line representing north-south. Okay? And then I have a reference point east of north or west of north. Okay, so we'll put in that line. Okay, and I'm going to make it dotted. And that's just going to be my reference point from north, either west or east. Okay, and we'll figure out some angles in a second. Okay, and we also have another imaginary line just representing north-south. All right, so let's read what it says. The call to Zulu indicates the bearing is 40 degrees east, or you could think of it as 40 degrees to the right of north from Zulu. So where would that 40 degrees go if it's 40 degrees east of north? Where would I put that? Okay, this is north. So where's, yep.
You put it in between the north line and the line, the signal line?
Yeah, in between the line for north, the dotted line, and the line from Zulu to the boat. The signal is coming in 40 degrees to the east of north. Okay? And if that's all the information they had, all they could do was tell you the boat is somewhere along that line. Okay, the other station also has an information. It's coming in at an angle 30 degrees west of north. Okay, so that's going to be here. The signal is 30 degrees to the west of directly north. Yeah, so in this case, I think the boat, I should have probably, to scale, should have drawn it closer to the other station. That's okay. Okay, and our goal is to find out the length from Zulu to the boat and from X-ray to the boat. Okay, what can I find next? I've got these angles, but these aren't really part of my triangle. They're outside my triangle. Aiden?
Find that complementary angles,
Yeah, so what's the complement of 40?
50.
50, and the complement of 30? 60. Right. And yep, we could get that third angle. How much is that one? 70. You definitely need that third angle. And now this is just a law of science problem. Okay, let's label our sides. I guess let's call this side A and B. Okay, a little confusing because we used English letters for our angles, Zulu and X-ray, just because that's the name of the Coast Guard stations. Right. So let's find A first. All right, what would be my law of signs I would set up to find A? Yeah, Tom?
Sine 70 degrees over 120.
Yep, definitely going to use that for both. Sine 70 over 120. Equals, and what's going to go on the other side to find A? Go ahead.
Sine 60 over A.
Yep, sine 60 over A. And we'll solve that in a second, but let's set it up for B too. Okay, we're going to reuse that sine 70 over 120. Okay, what's going to go on the other side of this proportion to find B? Sine 50 over B. Okay, so I think the hardest thing in this kind of problem is just taking all the information they give you and making a picture. If you can make the picture, then the problem is very easy. Okay, but making the picture can be a little tough. So A is 120 sine 60 over sine 70. Okay, so we'll find that in a second. And John, how about B? How are we going to get B in this one? Remember how you solve a proportion, what you do?
120 times sine 50.
Yeah, good. You got 120 sine 50. Yep. And then what else do you have to multiply?
Sine 70 over B.
The sine 70 times B. Okay? And what's going to happen when you multiply sine 70 times B? Then you're going to have to move sine 70 to the other side by dividing. Okay, and that's B. Okay, so any questions on how we got A or B? Does anybody have the decimal for either A or B? Will we get there? About if you're closer to my desk, why don't you guys find A, and closer to the window, you guys find B. And if you're in the middle, just do whatever you want. Yep. Ashley, you have the answer for A?
Yeah, 110.593.
593. And that was miles. And how about B?
97.82.
97.82. Okay. Right, so knowing the distances from the Coast Guard station to the boat, that might be one factor they use to determine which station should send out a rescue, or maybe both stations go. But again, you also got to take into account the boat drifting, maybe wind. If the wind is blowing towards the boat, maybe it's faster for one station to get there because they don't have to fight the wind, whether it's a helicopter or a boat they have to get there. Okay, but at least they know the distances from each station to the boat. Okay. Any questions about that? All right, so I think that finishes up the good part of our law of signs. In this case, how come common sense-wise there aren't two answers for A and B? Those cases didn't come up at all here.
Because you know exactly
Yeah. Okay, the information they gave us, we didn't have to worry about it. And since it's a real life problem, there is only one distance between the boat and the station. Okay, it's not like the boat could be here or here. Okay, we know exactly where the boat is. All right. So the homework, it's on the same page that you guys had on last Thursday at academics, page 435. And it's 4, 9, 11, 13, 14, 18, and 19. Okay, 18 and 19 are word problems. 19 is just like the Coast Guard one, except it's about a weather forecast spotting tornadoes. So instead of a boat, you have a tornado. Same idea. Great, so we'll take a look at that tomorrow, and then we'll finish up solving oblique triangles with law of cosines.